All right, we're going to go over some of the homework problems that were due today. Number 5 is the first one. We need to solve this differential equation. I'm going to first rewrite y prime as dy dx to help us separate variables. So I will have to divide 2 plus x, or multiply by 1 over 2 plus x, and I'll have to divide 3y to get 1 over 3y is equal, or dy is equal to 1 over 2 plus x dx. We are ready to take the antiderivative of both sides. Now, the antiderivative of 1 over 3y. Well, let's say we don't see it immediately. We'll set u equal to that denominator. du would be equal to 3 dy. dy is equal to 1/3 du. So if I substitute in, I'll just have that 1/3 times the 1 over u. And I didn't really need to do that. It's unnecessary. Could have just did 1/3 times 1 over y. And the antiderivative would be the log absolute y times 1/3. Plus a c, but we will worry about that on the other side. This is the same deal. They're actually, if you set u equal to 2 plus x, we wouldn't have anything that would need to be changed. So I just can take the antiderivative of this. It would be log absolute 2 plus x. Plus a c. This is our general solution. If we wanted a y equals solution, and we're going to be asked to solve these for y, we need to first multiply everything by 3, giving me log absolute y is equal to 3 log absolute 2 plus x. 3 times the c would just be c. Then I'm ready to solve for y by taking e to the power of both sides. This would be absolute y equals e to the 3 log absolute 2 plus x plus c. We know we can bring that down to be e to the c times e to the 3 log of absolute 2 plus x. And we can assign that e to the c to be just a c, and it could be a positive or negative. Okay, so this could be your solution. You probably are thinking, well, doesn't e to this log cancel? Isn't it just like 3 absolute 2 plus x? And it's actually not. That's because of the power property of exponents. If I have like x to the 2 times 3, I can write that as x squared cubed. So this is e to the 3 times log 2 plus x. So 3 times log of 2 plus x. I actually could rewrite this as e to the log of 2 plus x cubed. So now I can actually simplify e to the log of absolute 2 plus x to be c absolute 2 plus x quantity cubed. And this would be, your simplest form of your solution to your differential equation. Okay, so using this power properties, we simplified this to be that. Let's do the next one, number 6. X, y prime is equal to y. Well, I'll start by rewriting it. I'll then separate my variables. I'll have 1 over y dy equals 1 over x dx. I can take the antiderivative of both sides. Antiderivative of both sides is log absolute. You have the c over on that right side. Now we can just leave this. If we are asked to solve for y, I believe we are asked to solve for y, we must take e to the power of both sides. To isolate y, I'd get absolute y is equal to e to the log absolute x plus c. We can bring that down to be e to the c. I'll show you for this one the every single step process. That'd be e to the c, e to the log absolute x. E to the c is just c. You can assign this positive c, since e to the c is always positive, a positive or negative value by getting rid of that absolute. And, of course, we can skip these steps in the future. We can even skip the first step, we can go straight from here to here as long as we know what's going on. And the last step would be to simplify that e to the log x. Okay, so it turns out something as simple as a constant times the absolute value of x will satisfy this differential equation, which makes sense if I divide that by x, y over x. If you think about the absolute value of x, let's just look at 1 times the absolute value of x. It's just these slopes are all 1. All the points are going to be like 5, 5, 4, 4, 3, 3, 2, 2. I plug in 5, 5, 4, 4, 3, 3, 2, 2. All those slopes are 1. So that satisfies that for sure. All right, next one, 15. So we want to solve this differential equation. We also want to sketch what our solution will look like if it passes through the point 0, 0. So here I can see I have these horizontal tangents, but then I have some vertical tangents. It's almost like we have to shoot over like this. And then flatten out right there. And maybe over here it's the same way. Shoot up. And then flatten out. But we'll see. I'll solve this. 1 over 6 minus y dy is equal to x dx. So this is a great example of something that looks easy to take the antiderivative of, but everybody trips up and makes a mistake. So I would actually think that the antiderivative of this is log absolute 6 minus y. And over here on the right side, it's 1/2 x squared plus the c. But this part is actually incorrect. Okay, we're actually missing something. If I took the derivative of log 6 minus y, I'd have 1 over 6 minus y times the derivative of negative y, which is negative 1. I need that constant out in front to counter that. Another way you can see it is if you use u substitution, u is equal to 6 minus y, du is equal to negative 1 dy, dy is equal to negative du. You'd have the antiderivative of 1 over u, negative 1 du. So this negative needs to be here, okay? But this is the general solution. I'm actually going to graph this in Wolfram, see if it looks just like the picture that I came up with. So negative log absolute 6 minus y equals 1/2 x squared plus a constant c. I'm just going to leave that out. Yeah, it looks just like that. We can kind of see that. Maybe I'm just a little too sharp in the points here, but you know, I kind of have that picture, and you can kind of see this picture up here too. So not bad. Let's find the c though, because we need to find that solution. So through the point 0, 0, I'll have negative log. You know, I'm going to solve for y first. Let's practice solving for y first. Multiply everything by negative 1. Take e to the power of both sides. I'm going to skip the steps this time. We have 6 minus y is equal to, this would just be c e to the negative 1/2 x squared. And then, of course, I can get rid of these absolute values because c can be positive or negative. Solve for y, subtract 6, divide by negative 1. Y will equal this c e to the negative 1/2 x squared plus 6. Okay, and I'm told that I have the point 0, 0. So in this situation, 0, c e to the 0 plus 6. So c has to be negative 6. So my solution in the form y equals would be negative 6 e to the negative 1/2 x squared plus 6. Yep. Now let's look at what that looks like. Hopefully it looks just like this, but sometimes when you're solving for y, things can get a little bit different. Oh, look at that. There is a function. It's a function. It looks just like my graph right here. It should really kind of be plus or minus, which is why you can have both sides, the entire, but this being a y equals f of x, this is a function. This satisfies the differential equation. It's just what I drew. So that's cool. So there's that solution. We got two more, 16 and 24. 16, we should see our solution should be probably like a hyperbola, something like that, probably with this piece down here if we had just our implicit equation. So to have 1 over y dy is equal to x dx. Take the antiderivative of both sides. I have log absolute y is equal to 1/2 x squared plus a c. I can then graph that, see that that would be that. Why not? Log absolute y equals 1/2 x squared plus a constant. If I don't have, it's probably going to like connect. Oh, there you go. So just what I guessed. So that's my solution that has derivatives that are equal to x times y. I'm going to go ahead and solve this for y. E to the power of both sides, I get absolute y is equal to c e to the 1/2 x squared, and then apply that plus or minus to c. Okay. And I think they actually solved that, right? Yep. Y equals e to the 0.5 x squared. They should have the c, but we didn't have a c. It's what happens if we put a c in here? Yeah, it would just be e to 5. They didn't really change it. Okay, so that's the solution for 16. 24, last one, and then we'll look at the free response. Dy dx is equal to 2y over 3x. I'll multiply by dx. I will divide by 2y to give me 1 over 2y. dy is equal to 1 over 3x dx. Anti-derive both sides. Really today for your quiz, it's all about being able to solve these differential equations and finding the particular. And all of your answers need to be in the form of y equals. So all the steps that I'm doing are steps that you have to do for your quiz today. So this is that antiderivative, this is that antiderivative, plus a c. We can plug in 8.2 now and find c, or we can just go ahead and try to solve this for y first to find the c later. I'm going to do that. I'm going to multiply everything by 2. I get 2/3 log absolute x plus c. Take e to the power of both sides, giving me absolute y is equal to, and of course I'm going to just skip those steps, y is equal to c e to the 2/3 log of absolute x. This could be considered your solution, but you can do more. You can actually simplify this. This is a power times another power. I can rewrite this as e to the log x to the 2/3. So e to the log x is that's just absolute x. I have c absolute x to the 2/3. I was told I have the 0.82. Well, I can plug in 2 and 8, Absolute of 8 is just 8. 8 to the 2/3, the cubed root of 8 is 2, squared is 4, so I get 2 is equal to c times 4. C is a half. Giving me my particular solution, y is equal to 1/2 absolute x to the 2/3. Now, let's say you didn't simplify all the way here, and let's say you just stopped here. Well, this could be a solution. This is totally fine. You know, it is in the form of y equals. You would just have to plug in 2 is equal to c e to the 2/3 log 8. And maybe you don't see like how you can simplify this. Well, you could just tell me that c for your answer is 2 over e to this. It's not nice looking, but it is a correct answer. 2 over e to the 2/3 log 8 times e to the 2/3 log absolute x. So this is, this is a solution. It's not as pretty as mine, but if you didn't know how to simplify that e to the 2/3 log x, you can just leave it like this. Okay, let's do one more. Let's do the second part of your first one. We will go over more of these next class. You had to do 1, 2, 3, and 4. I would say 2 and 4 are the toughest ones. Part B for number 1 might be difficult. So let's just get started. I'd separate these by dividing e over y, e to the y. So I'd have 1 over e to the y dy is equal to 3x squared minus 6x dx. Can then take the antiderivative. Now, the antiderivative of 1 over e to the y is not log e to the y. What you have to do is rewrite it as e to the negative y. The antiderivative of e to the negative y using u substitution to confirm things is negative e to the negative y. Over here, the antiderivative would be x cubed minus 3x squared plus a c. Well, now I need to solve for y because I want y is equal to a function. Well, that means I have to multiply everything by negative 1 to just isolate the e. So it's negative x cubed, positive 3x squared. Keep that as a c. I then have to take the natural log of both entire sides, giving me negative y is equal to the natural log of negative x squared plus 3x squared, or x cubed plus 3x squared plus c. And then I would have to multiply everything again by negative 1, giving me this as a y equals general solution. I know it passes through the point 1, 0, so 1 is equal to negative log of 0. Sorry, opposite. This should be 0. This is 1. Okay, so I get 0 is equal to, I can get rid of the negative there, 2 plus c. Now I need to think about how to solve this. You can either know that the log of 1 is 0, or if you don't know how to solve this, you can take e to the power of both sides to give you e to the 0, which is 1, is equal to e to the log of 2 plus c is just 2 plus c. That shows you that the log of 1 is 0, so c has to be negative 1. Giving you your particular solution, which was asked of you, of y equals negative log of negative x cubed plus 3x squared minus 1. Okay, that's your homework. Time to take a quiz. Long.